During the derivation of the modes in an optical fiber, at some point we introduced this constant kT. So pause the video and try to think about the physical meaning behind that constant. In the core, where we have refractive index n1, we introduced the constant kT1 squared, which we defined as k0 squared refractive index 1 squared minus kz squared. And then a similar thing for the cladding, where we have kt2 squared k0 squared refractive index 2 squared minus kz squared. So thinking about the physics of this problem, well, kz obviously is the propagation constant of our waveguide mode. That just tells us how the phase evolves as the waveguide mode propagates. And what about k0 n, so just generic refractive index here instead of just 1 and 2. Well, k0 n, we know that this is equal to the total length of the wave vector in that particular material, with the well-known abbreviation TLW. So if we take this kz squared here and move it to the left-hand side, it becomes obvious that this is Pythagoras basically. So we can draw a diagram like this, which is a diagram in k space, so the space where our wave vectors live. And this axis, for example, is the axis for the wave vector along the propagation direction kz. We know that wave vectors in a particular uniform medium will have a length which is dictated by k0 times the refractive index. So all of the endpoints of these wave vectors will be lying on a circle with radius k0 n. And if in this diagram we draw one particular value of kz, so over here, then Pythagoras tells us that what we introduced as kt here is indeed the transverse component of the wave vector, so in this particular direction. So this is the physical meaning behind this kt. By the way, do not confuse a diagram like this with a diagram that we had in the beginning of the derivation for the modes in the optical fiber, where we had a cross-section of the optical fiber with a refractive index n1 in the core and n2 in the cladding. Looks very similar, two circles basically, but they are very fundamentally different. The second diagram is the cross-section of the optical fiber. It's a diagram in real space. That's the space that you and I live in, where we have, for example, here the x direction and there the y direction, and where the units here are meters. This diagram, on the other hand, is in a completely different space, where we have wave vectors over here with units 1 over meter, so the reciprocal space.